All right, well, so we're going to get into the episode, of course. If you're wondering what on earth this is, you're watching a live episode of us recording Astronomy Cast, which is our weekly space podcast. And then we're going to stick around and answer your questions about space and astronomy for as long as Pamela's internet holds up. But actually, it's doing surprisingly well. Are you just on the...
Everyone is asleep.
Mm,
It's 5:08 a.m. on a Saturday. No decent human being is up using the bandwidth other than me.
right.
And this is okay because I just finished sleeping like 14 straight hours, so I'm wide awake. Next Saturday may be a bit more interesting.
How long are you going to be there for?
It's a 10-day trip.
Okay, okay. All right. You are a trooper then to get up at 5 in the morning to match noon Pacific. So thank you.
Well, the show must go
The show
on.
must go
And you
on.
had a you had an excuse that was unparalleled. You were on a ship.
It was
There's no such thing as streaming from a ship.
no, and
So
I bought the
I have no
fancy
such.
internet, the fast internet, and it was garbage. So there's no way that we would have been able to make anything that was even reasonably acceptable. So uh, yeah, but
And
now we're
being
back.
up at this early, I'm gonna go look at opossums after this. So
Aw. All right, let's begin the recordination whenever you're ready.
okay,
Coordinate
I
to
have pressed
recordinate.
record. It
I
is recording.
I
The
have also
levels
pressed
look
record.
good.
Okay.
Hi, Chad.
It's weird to have Chad virtual again after hanging out with him for 2 weeks in person. So here we go. Astronomy Cast, episode 501, Water Worlds. Welcome to Astronomy Cast, our weekly facts-based journey through the cosmos where we help you understand not only what we know, but how we know what we know. I'm Fraser Cain, publisher of Universe Today. With me, as always, Dr. Pamela Gay, the Director of Technology and Citizen Science at the Astronomical Society of the Pacific and the Director of CosmoQuest. Hey, Pamela, how you doing?
I'm doing well. How are you doing?
Great. We're into the new season. I guess episode 500 was our official beginning of the new season, but now we're back to our regular schedule. Of course, always looking to mix things up. You're in Australia now and will be for this week and next week.
It's true.
But like a complete professional and a trooper, you are recording at like 5 in the morning in a sleepy bed and breakfast in the outskirts of Melbourne.
It's fabulous, and our show's a teenager.
Aw.
Like we're 13 seasons old now. So does this mean that we get to cover all of the bratty discussions in astronomy now?
That's exactly it. Yeah, now it goes to that
Okay.
rebellious stage where it just tells us that
Okay.
it hates us, it hates us, it hates us. Not that that's my personal experience from this at all, having two teenagers. But I have something. I have something really important to shamelessly self-promote, and I'm probably going to do like even more for this. But I just want to begin what is going to be pretty much a straight month of shameless self-promotion, and here it is. Hold on. Boom. Check it out. So for the podcast listeners, of course, you can't hear what I just showed to Pamela. It is the Universe Today Ultimate Guide to Viewing the Cosmos. Oh, and Pamela can't even see it. Okay, hold on. Oh, yeah, she can see it. Okay. Uh,
I can see it.
yeah,
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 I
yeah,
got it.
yeah. Which is the new book written by Dave Dickinson and me, featuring, and this is the part that I'm proudest about, a foreword by Dr. Pamela Gay. So
Yes.
Pamela wrote the foreword. Dave wrote the book. I helped. And the help that I did that I'm most proud about, and I'll bring this up again and again, is the photographs. So we've got
Yeah.
probably more than 100 separate astrophotographs by I think 75 at least different photographers. And what's amazing about it, and I'm just going to keep holding it up, is that it's pictures that you've never seen before. Each one of these photographs was taken by an astrophotographer, an amateur astrophotographer, no Hubble Space Telescopes. Okay, fine, there's a few Hubble Space Telescopes in the book. But in general, the vast majority of the books that are in the photos that are in this book are all individuals. And this was really the goal, which was like, if we're going to teach you how to be an amateur astronomer, You aren't going to get access to your own Hubble Space Telescope. I want to show you what's possible as just a regular person with skill and patience and some reasonable gear. So, a huge thank you to all of the astrophotographers. It was kind of like herding cats to get everybody involved, but in the end,
Feral cats.
feral
You were
cats. But
herding feral cats.
exactly. But in the end, I think it worked out great, and I think everyone's going to be really, really pleased with what the final product looks like. It's available for pre-order right now on Amazon's and Barnes and Nobles and things like that. And I'm not exactly sure what's going on, but for some reason you can pre-order it on Amazon US for $18.89, while the actual print price is $28. And so I'm not exactly sure. Maybe that's just the pre-order price. Someone should help me get to the bottom of this. If this is some kind of special promotion and incentive that I should be mentioning. So what I'm saying is that it appears that the price is extra cheap by quite a bit. $18 for a hardcover, full color book.
This is a true coffee table book.
Yeah, well, yeah, maybe. You know what it feels like? It feels like the player's handbook for Dungeons and Dragons. If you want to sort of imagine a book that it feels like, if you've got one of those, this is almost
But
exactly what it is.
but that thing you leave on your coffee table because
Yeah,
every person who enters your house will want to flip through it,
yeah,
that's
that's,
what this is.
yeah,
Now,
absolutely.
I have one tiny shameless plug, tiny
Okay,
compared to this.
yep.
You just returned from doing one of the Astro tours with Dr. Paul Matt Sutter, and I have now posted my tour for next year. So if you want to go travel through the American Southwest, which is kind of my home, it's where I spent all of my summers growing up. You can do this. Go to astrotours.co/starstrider and register today, and we will see the great observatories and the great deserts of America. This is like nowhere else in the world. If you're going to come to the United States, this is where I would send you.
Agreed. Apologies, all the shameless self promotion, but we've been gone for several months, so we got to catch up.
Yes.
So people go to astrotours.co to sign up for your trip. Do a search on
Slash Star Strider.
Sure, but it's they can scroll down, right? And then they're gonna have to have to
Yeah.
explain how to misspell Star Strider. It got very complicated. You just made it more complicated. So go to
Sorry.
astrotours.co, browse down until you find Pamela's trip. Do it. And of course, if you want to pick up her book, pre-order it now. Go to Amazon, search for Universe Today, and I'm sure you'll find it pretty quickly. So, all right, let's get into the actual show. We're now learning that the vast majority of potentially habitable worlds out there are actually icy moons like Europa and Enceladus. Good news! There are hundreds, if not thousands of times more of them than worlds like Earth. Bad news? They're locked in ice. What have we learned about the water worlds and their potential for habitability? So I think we've talked a bit about water in the solar system. We've talked a bit about the icy moons in the solar system. We've mentioned a lot of these discoveries about hydrogen gas that's coming out of Enceladus, the geysers on Europa and Enceladus. I think if one huge theme that has gone in the background of planetary science while we've been doing this show, if we talked 12 years ago, where should we be looking for life? We'd say Mars or Earth-like worlds in the
No.
habitable zone. Now it's water worlds. It's Kevin
And
Costner paradises.
right. And we have two different forms of water worlds that get discussed in the literature. And it will break your brain slightly if you're not careful doing these searches, because we have these massive super Earths that are getting discovered, snuggled up next to little red dwarf planets, not red dwarf planets, red dwarf stars. And they appear, according to the models, to be completely covered in water, perhaps. And then in our own solar system, we have all of these moons that, for reasons we can't always explain, have oceans underneath, with Ganymede is one of the theories, and then
Yep.
are coated in liquid water and ice on their surface. water is common. It comes everywhere. And we're finding new and ingenious ways the universe has decided to heat it up every year that we do this show.
And it's not just you're talking about some of these larger ones that are huddled up to the red dwarf stars. I mean, even some of the smaller ones, the ones like the TRAPPIST, they're now thinking that the TRAPPIST
Yes.
planets could very well be large amounts of water, like 50% water, higher, like enormous percentages of water compared to what we see here on Earth and what we have discovered in the solar system so far.
And what gets me is how they're figuring this out. We can't exactly directly image the surface of these worlds yet because we haven't spent the money to build those telescopes yet. I'm really hoping we'll get there. Uh, but right now, what ends up happening is we have these worlds are getting discovered by Kepler, and there's a whole bunch of them. Kepler 62e is one of the ones that gets the most attention. But there's a whole bunch of these different worlds, and we can observe them transiting in front of their stars. So we know how quickly they're moving in their orbit. We are able to see how long it takes them to dim, and so you have your object, and as it passes in front of the star, it takes time for it to go from completely beside the star to completely in front of the star. And that amount of time that it takes it to move also gives us the width of the planet. So with these transiting systems, we have the ability to physically measure the size of the planet if it's the right kind of dip. Once we know how big the world is, we know how it's orbiting, we can start making assumptions about what its mass is, and then the modelers are free to model and they plug into their computers. Well, you throw these things in, you throw these things in, assuming, okay, if the star has this composition, the solar nebula would have had this composition. And in the models, it works out what elements would have gotten blasted to the outer solar system during planetary formation, what elements would have been left behind, what should this world have been made of. And it appears that to get the composition, to get the sizes we're seeing, you need a world covered in water.
And let's tackle these two flavors of water worlds, frozen and liquid, one after the other. For the ones that are close in, that are warmer and have been, I mean, here in the solar system, if you get too close to the sun, you get your water blasted away because of the solar
Yes.
radiation. So how are they thinking that maybe these planets are able to hold on to their water?
Well, it all comes down to what kind of star is it. I don't know about you, but I have incandescent lights in my house in random places still because I'm a bad human being. And I know that the 100-watt light bulbs, if I touch those suckers too soon, totally going to burn myself. Whereas the lower wattage bulbs, the not turned up all the way on the fader bulbs, if I want to replace those with a fluorescent bulb, I just turn them off and grab them, and it's good. Stars, it's the same way. If they're big, they're hot, they're gonna get rid of all of the water and burn that planet. You have a smaller, redder, cooler star, and water can be liquid but not boil away.
Right.
These stars also go through a different kind of launching into existence, whereas a red dwarf, it's going to be an angry little X ray jettisoning object for a while, but it's not going to go through that prolonged period of being super hot.
So it's almost, I mean, the star matters, and so as you're finding these smaller red dwarf stars and you're finding these planets around them, the conditions are different. You're not going to get that extreme temperatures and powerful. I mean, the solar winds can be bad, but you're not going to get the same
Yeah.
temperatures that are going to blast away the particles of water. And it sort of says that in fact there probably was a lot more water in the inner solar system back in the early days. It's just the sun
Oh, yeah.
sun was having none of it and was just getting
Yes.
rid of it, and it was only what could
Yes.
form or could be collected onto the earth that we were able to hang on to it, and the rest is blasted out into deep space. Goodbye
And
forever.
most of our water is actually believed to have been delivered later. It's now thought that it probably came from meteorites hitting us that still had a lot of water trapped in their rocky matrix. So we don't have our own water. It was taken away from us by an angry young sun.
Well, I
These
know that
worlds
this
didn't
is
have that
still a
star.
controversy. Yeah, that
There
that
is, yeah.
right, like delivered, as you said, that delivered by comets was, I think, the long-standing original theory, and now, as you're saying, that it's, maybe water trapped in the matrices of meteorites and asteroids and rocks instead, and even
Yes.
possibly it was just scooped up in situ by the Earth as it was going around the sun in that cloud of water. Um, so, what are these worlds like? If you could visit them up close, what would you see?
Well, water as far as the eye can see, clearly. But beyond that, you'd have, because they are closer to their stars, these objects are often as close as Mercury is to the sun. You would have this glowing, obvious to the eye, red, large object in your sky. They would have thick, humid atmospheres, much thicker than our own atmosphere. So you're going to have that extraordinarily rich blue sky. If you've ever had a cloudy fish tank, when you first turn the light on, the tank appears to be, as long as it's like cloudy with even scattering and not like green cloudy because it's cloudy with algae. If you have a cloudy fish tank, it appears to be filled with rich blue water. That rich scattering of light in a human atmosphere is what you'd experience from the surface of one of these worlds. If you're talking blue skies, large red star, the sunsets would go into deeper shades of purple than we have here on our own Earth. Um, and if the atmosphere is thick enough, you're going to start scattering things so that it's sunset all the time.
Yeah. And then what about habitability? I mean, obviously, if there's no, like, if it's just a ball of water floating, the it might be tough.
Well,
A
they're not
sphere
balls
of
of water.
water. No, no, no. But I'm saying, like, obviously, if it's a sphere of water, that makes life difficult. But the point is that the mixes are high. Like here on Earth,
Yeah,
water accounts for, and I forget what the number is, but like less than 1%. Like it's a tiny amount of water compared to dirt. But some of these
right.
worlds could be 50%, 70%. Like they're really a tremendous amount of water with a rocky core underneath it. Like, what about habitability for these places?
Well, it's as long as you have the other stuff, you're good to go. And so these worlds are considered to have the metal iron cores, the other atoms rich in them, just deeper down. So you can imagine that those cores still would have the trapped heat. They would still potentially have, at one point earlier in their existence, been capable of seeding life deep in ocean vents. Once that life is seeded, you have that potential for life migrating all throughout the ocean depths. We don't actually know on our own planet, did life originate near the surface or did it originate deep in the someplace like the Marianas Trench, but when the Earth was a completely different setup. Without knowing where life originates or if it originates both places, we can hope that life could have originated deep down in the murky, dark depths of that ocean and then evolved to fill all the different ecosystems and all the different heights within the water where different amounts of light permeate. And one of the articles I read prepping for this actually said, now imagine we have flying fish here on Earth. We have things like rays that'll jump out of the water and splat back down to scare the bejesus out of their prey. Well, imagine the leaping fish of these worlds that catch glimpses of probably clouds and not stars as they jump out. These worlds are considered to probably be mostly cloudy because they're just that humid.
One of the things that's really interesting, there was a great piece of research that was done earlier this year, actually just a couple of months ago, about people ran some simulations for what a very deep ocean water world would be like. And so one of the big assumptions was that they couldn't mix essentially the atmosphere couldn't reach there's no way for the
Yeah.
material to get from the bottom of the
You
ocean
can't
up to the top,
oxygenate the
and you could,
bottom. Yeah.
and now according to their simulations, in fact, it's probably a lot more likely, and in fact they could. And one of the things that's really interesting is that the world could maintain its temperature for a significantly longer period of time, billions and billions of years, around a red dwarf star, because they're so stable in the long term. And I think the other part that's really interesting is that, I mean, we know that red dwarf stars are so volatile in their youth, where they're blasting it with
But the
these,
water,
but the water is protective.
yeah.
So suddenly you've got the perfect protection, a lot of protons in the water, matched with the perfect long-term temperature stability of a red dwarf star. So now these places are looking pretty intriguing.
And this causes us to then go down the more science fiction pathway of how do you detect and how would civilizations in these worlds exist? And it's one of those firm reminders that our own ocean dwelling mammals may have advanced language. We're pretty sure the whales have language. We just don't know how advanced and how conceptual it is yet. Um, but because you're underwater where they're not going to be dealing with electricity beyond shocking one another like moray eels, they're not going to develop the kinds of technologies that we've had to create here on the surface of the world. So you can end up with advanced societies that have arts, have language, have song, but may not have any form of technology at all other than tool usage. And we do see all sorts of tool usage in the ocean.
But even if they, I mean, if the they wouldn't be able to do very well beyond perhaps a kilometer of that top water. So what kinds of tools would they even be able to get access to? It would be a very strange kind of society. It's kind of sad. It's clearly a science fiction story that someone needs to write. Um, Now I'd like to go shift gears now and talk about the kinds of worlds that we see now in the outer solar system places, because potentially there are hundreds of these worlds just in
Yeah.
our own solar system.
And I'm
Not the
not
ones around the red, but things like Europa and Enceladus.
yeah.
They, as you said, they think there's Ganymede, they think there's Titan, perhaps even Pluto, Charon,
I'll give you tens.
Sedna.
I'm not sure about hundreds.
So the
Tens, I'll
no
give you.
the some of the research that I saw was not only hundreds but potentially thousands of times in the Milky Way, more of these icy
Oh, Milky Way. I thought
worlds.
you were saying in our solar
Well,
system.
that's why I
Okay.
went to hundreds in our solar system. I was right. So if it's thousands in the Milky Way, I went with just hundreds in the solar system. I can send
So
you
I'm
the
going to
paper.
still nope that and go with tens.
Sure, feel free. I'll send you
But
the paper if you want.
so so within our solar system, we see worlds that have liquid beneath their surface that are heated through a variety of different means that we do and don't understand. Ganymede, not Ganymede, sorry, Ceres, wrong, large cratered round object. Ceres is the largest of the asteroids, and it was discovered by the Dawn mission to have what appears to be cryovolcanism that has been ongoing with hundreds of candidate volcanoes having been discovered through imaging where they look to find the hills that are properly slumped to represent extinct volcanoes. And they're able to trace back how essentially these cryovolcanoes appear to have turned on and turned off across the decades and centuries and millennia. And now we're able to see at least one recently active volcano on its surface currently. And exactly what would trigger this pressure buildup of icy liquid beneath its surface is something that we're still trying to figure out. Here on Earth, we know that part of the reason that our planet is warm on the inside isn't just leftover heat from the formation of the planet, but there's actually ongoing radioactive decay. If you live in New England with granite, you know radon builds up from these nuclear decays. And it could be that, well, Ganymede has one expletive of a radon problem because of the built up heat from nuclear decay processes within the world. So that's one way that you can get subsurface oceans, perhaps. You have, going further out into the solar system, you have our quintessential Europa and Enceladus, which are these fairly large, in the case of Europa, very large icy moons that have a rocky core deep down, have a argued about how deep liquid ocean above that, and then an argued about how thick icy crust on top. And with Europa, it's very clearly heated through tidal stretching and compression from its interactions with the other moons and through its orbit around Jupiter. With Enceladus, we're still working on the dynamics because we didn't think the tidal forces it dealt with was enough to trigger the heating necessary to keep water liquid. Then when we look out at Pluto, it's just like WTF Pluto.
Mm-hmm.
How? So there, I've even heard ideas that it got reheated through a massive collision that created that heart that it has, and that led to liquefaction of subsurface ices.
But there's even potential evidence of cryovolcanism on Triton, which is the moon of Neptune. Uh,
Yeah.
and so the thinking is that all of these icy worlds, to some extent, even Sedna, even Eris, even the Goblin that has just been discovered, that they all have, to some extent, as you mentioned, because of this leftover radioactive decay that's going on in them, some amount of liquid water underneath an icy shell. And this is where this calculation comes from, that the vast majority of the universe, the if you wanted to look for places for life, you would start with these, which are the more common places in the entire universe. But the problem, of course, is that the amount of chemicals and energy that they have at their disposal is far less than what we have here on Earth, being closer to our sun.
And this is where it comes down to which number do you go with is based in part on how do you figure out how low can you go in terms of mass and still have this liquid water trapped somewhere within it. With something as large as Pluto, as large as Sedna, as large as Eris, I you can start to imagine there's enough material to cause prolonged heating. Whereas as you start to get down to smaller and smaller objects, you're just going to not have enough radioactive decay to liquefy much of anything. But where that boundary is, we don't know. We really did think up until New Horizons got there that Pluto was going to be an utterly solid, boring, cratered world that would look a lot like Ganymede, and we were wrong. We
Mm-hmm.
were really wrong. So I go with tens because I think you do need to be a larger object. You need to be more of a Charon-sized object. You're going smaller,
I'll
betting more on these potato-shaped
I'm
blocks of
I
ice.
am just regurgitating research done by Avi Loeb and team. So I'll send you his paper if you want.
It's all
Thousands,
right.
but sure, go ahead, no problem.
in
You,
our in our solar system, a
sh-
thousand in our solar system.
I will send you the paper, and you can take a
Okay.
look at it. But in no, but he's proposing that it's 1,000 in the Milky Way, just in general,
Yeah, that
for
that
for
I'm totally good
every
with.
for every Earth sized world in the habitable zone of a sun-like star, there are 1,000 ice worlds which have liquid water underneath a surface of of ice. So obviously, tens in the solar system, sure, but if you count up, because the vast majority of them are these red
Yeah.
dwarf stars, and who knows what's out there. So, but the point is that if we want to find life, but finding life would be super difficult because they are under all of this
Yes.
ice.
Yes. And we actually have experience with how difficult this was. We talked about this in an episode several years ago. There was a Soviet and then Russian project to dig into the deepest, highest altitude lake here on Earth, icy lake, and sample the liquid water. And they went down, I believe it was over a kilometer, to get to that water. And it took them years and years and years to get there and to get samples to look and see if there's life in Earth's deep lake. And here on Earth, we can like use giant ships, giant airplanes, helicopters, big machinery, no restrictions on how much energy is required, no restrictions on the weight of what we're using. And it still took years and years and years and years to get a water sample out of this lake. And it was still high risk because how do you not contaminate it? And we don't exactly have the ability to do this on another world. The best so far that I've heard as an idea, my personal opinion of best that I've heard so far as an idea, is a small little instrument on a heated wire that heats its
Yep.
way down, and because the wire is heated, it's able to keep sliding. And in this case, you're not digging a tunnel; you're simply allowing something to slowly move down. And here it's all about the resistance, and you have something generating electricity at the surface. But
This technique has actually been used here on Earth in Greenland. So they're actually, you mentioned it was Lake Vostok, and they were attempting to
yeah,
get down to this ice, this subglacial lake that's in Antarctica, and they used this drilling method to do it, and it was very difficult and very laborious. And I don't know the actual distance they got down, but I think it was dramatically deep. But a similar technique has been done to bore out all of the ice cube observatory in Antarctica, and they learned a lot of lessons, and they were actually able to build that telescope relatively rapidly, which is a big neutrino observatory. But in
yeah.
Greenland, some new research is being done where they're actually taking, as you said, this heated probe and letting it melt its way down, reeling out wire as it goes, and then the borehole freezes behind it, freezing this wire in place. And in theory, and I did a whole video about this is why it's so present in my brain, is it would take you 1 to 3 years, depending on the size of the probe, to get down to the sub ice sheet layer on Europa, for example. But we don't need to go to that work because Europa and Enceladus have been so kind to spew this material out into space for us.
And this is true. We've been able to detect but not measure anything fascinating about the water geysers on Europa, thanks to how they affected one of the, I believe it was a magnometer that was on the Galileo mission. That was found by going back and reanalyzing the data once Hubble had seen the geysers to see if we could see the effects. And then, of course, the Cassini mission quite purposefully flew through a plume of Enceladus and captured up the material to put through the mass spectrometer. And as we plan future missions, the question is what so anything we throw through a mass spectrometer is probably going to die in the process. Uh, but what mixture of elements and molecules do we look for that can indicate life exists here? Because it's one thing to find all the stuff that's needed to eat. That's we find the ingredients for alcohol, we find amino acids, we find all sorts of complex molecules all across the galaxy. That's not a question. But how do we find evidence that there's life by analyzing the data that comes out of that mass spec?
Yeah, and so you've got the Europa Clipper, which is going to be on its way to Europa relatively soon. It's going to fly through these plumes, and as you said, how good will it be able to detect? But at least it's a shot at it, and there'll be all
Yes.
kinds of organic chemicals that, in theory, it's going to be able to see. So it's a fascinating time, both with the exoplanet discoveries that have been made with the red dwarf stars, with the really interesting water-based worlds that are around them, that suddenly the biggest threat to life has now potentially been protected by this amount of water. And then once you get outside the frost line, the vast quantities of water that's available in these solar systems. It is an exciting time, and a time to really flip the way you look at the search for life. Place your bets. Where do you think we'll find
I
life?
I'm really hoping that we are able to find tiny life existing in brine on Mars that we can just like go out and directly measure with robots in our lifetime. But I suspect that the highest density of life in our solar system off the Earth is going to be found on one of these icy moons.
I cannot wait for us to be able to make that discovery. Pamela, thank you so much.
Thank you.
All right.
The
Save.
sun is slowly coming up outside.
All right. Episode 501. That sounds so cool.
Yeah, we have been doing this for a long time. As you said, you now have two teenagers.
Yeah. Yep. They were, I'm trying to think, 1 and 3 when we started, and now they are 16 and 14.
Yeah.
It's about to turn
And I had
17
it
and
pointed out
15.
to me, I am a terrible human being who does not have children because I didn't think through that I shouldn't point out the misbehaviors your son had when I first met him. So I owe your son
Oh, do you?
apologies.
Okay. I'm sure
Oh,
he's.
for telling embarrassing stories.
Oh, well, that's one of those circle of life kind of things, I think.
It's true.
All right, let's get into to everyone's questions. Now, a couple people were asking about how the wires work with these. So the wire freezes in place. So the wire's on a big spool inside the
Yeah.
probe. As the probe is melting its way down, it's spooling out wire behind it, and then that wire is freezing into the borehole as it goes. So you just need a strong enough wire to be able to handle this much distance pulling on it,
Yeah.
and then it's all frozen. So you don't have to worry about that.
But it can also be generating enough heat in it that it maintains a gap around it so you don't have the compression issues
Yeah, but I
because
think
water expands.
right. But I think the point is that you don't try to keep the wire melted at any point. You're just trying to use it as a way to communicate through it. You're trying to keep power going down to it. Although in some cases you have a chunk of like decaying plutonium at the front of the probe, and that's what acts as your heat source as the thing goes down. Arjun asked if you could bottle some of the water, would there be a way to assess if the metabolism is happening? So if you took if you filled up your water bottle with Enceladus water and brought it back to Earth, that would tell you quite a bit, wouldn't it?
Yeah, it would. And I just have to pause and point out that it has been discovered in the chat that we just recorded episode DI in Roman numerals. And we have now hit the point where we will have interesting Dungeons and Dragons rolls for our episode numbers. We will have an episode D20 because capital D is 500 in Roman numerals.
I see.
But yes, if you bottled up water and you brought it back to Earth, that would be fabulous. And that is like every high school
Yeah.
science fair project that wasn't a volcano ever.
Yeah.
Go
Yes,
out,
please,
collect local
Arjun.
water.
Could you do that? Do you have a way to do that? Because that would be wonderful. Thank you. Please do that. XYCon123. So could there be a planet with higher gravity than Earth with liquid water on it, but the higher gravity would make it move
Yeah.
more like a jelly than a liquid that we're used to here on Earth? If far down, right? The
So
pressure.
jellies move, but it still doesn't move like a jelly. Because one of the things about jelly is it is a loose solid where a given molecule is attached to the molecules around it. So the attachments are flexible enough that it jiggles, but one molecule isn't going to move over to another place.
Right.
With fluid, no matter how pressurized it is or how mercury is a good example. It's a fluid, it's just a slow moving fluid. Um, it the molecules are free to go all over the place. The way we describe is it a solid and jello counts. A liquid or a gas is based on how the molecules are able to move. And so
Right.
jello is a chemical state. And
Right.
and yes, you'd have highly pressurized, not as fluid liquid,
But it wouldn't be
but it's
jelly. Yeah.
different than
Right.
Jello.
Well,
Not a gelatin.
and I mean, there have been a whole bunch of ice, various flavors of ice that you get when you compress water, but also heat it up. That
Yeah.
you get all these different versions of it. When you think about Jupiter, people always ask, if you flew into Jupiter, could you fly down to the solid middle of it? But no, you go down just a few hundred kilometers into the atmosphere of Jupiter, and you're now moving through hydrogen and helium that is as hard as a rock, right? Like it's not a fluffy gas. The whole planet is not fluffy gas. The whole planet
Right.
is this incredibly dense ball of hydrogen and helium that is denser,
Yeah.
as dense as rock. And so at a certain point, it is
You
not
you
what
can
you
have
think.
you can have plasma gas where the atomic density is greater per cubic centimeter than the density of like glass in a window.
Yeah. So Astro B is asking, how many years will it be before we get a probe on Europa to look for life? Place your bets.
Ask governments that fund these things.
Yeah, well, so knowing how it all goes horribly wrong, being a part of a decadal survey, place your bets. Don't make me be the one who predicts
before
this.
before it gets to Europa.
A
I'm going to go
probe
with
that is going to land on Europa and search for life.
so until it launches, I'm going to say no less than 10 years.
And so it would be something after Europa Clipper. Maybe
Yeah,
something in the decadal survey right now. Maybe the next one.
yeah,
And it'll probably just be a lander to the surface and it'll taste the ice.
yeah.
Hi, Gordon. How's it going? Welcome to Astronomy Cast. I hope now this is one of the people who was on the cruise with Paul and myself. It was so funny. Some people were there because they were fans of what I do, and some people were there because they were fans of what Paul does, and it was hilarious to have these two groups of fans trying to convince each other that they should watch the other thing as well, because some had never seen the other part. So anyway, it was interesting to bring these two communities who would, in theory, just all love the same stuff, who had just happened to come at this from a different way, right? So there's like a bunch of people who were like,
Yeah.
I love Ask a Spaceman, but I've never heard of Astronomy Cast. What is this Astronomy Cast that you do? Yeah, and it was
Open
like,
iTunes.
yeah, open iTunes, do a search for astronomy, you might find us. But still, it always shows me, and people who are like gigantic astronomy fans have watched lots of stuff, and yet it is still so difficult to find various shows, and it just
It's
shows that
true.
it's so different, the way reaching an audience works these days than it did back in the olden days. So anyway,
Yeah.
but there you go. Gordon is up to episode 11 already, so congratulations. You got 500 more, and it's a different Gordon than
Yes. Yeah. No, we now have two
two
Gordons. We have
Gordons. Yeah,
Keeper of Maps Gordon,
yeah.
and what is the other Gordon?
Well, he's XYCon 123. He's from Ireland. So
Okay. Okay.
Capital H is asking, is it silly to put a microscope on a probe to look at a capture device and beam the pictures back to complement the mass spectrometer? So you had said, let's
Yeah.
let's use a mass spectrometer, but could the Europa Clipper or something like that have a microscope on board and it captures particles and just takes a quick look at them?
Well, you can imagine with Mars Curiosity rover and some of the other rovers, we've had these bore devices that go and they
Yeah,
clear off the surface and then they take a close in picture, and it's just an imager with optics. This is kind of what we do. And I would love to imagine a situation where you have an optical system that if you look through it one way, slide in a camera, it's a telescope, slide the camera out, looking at the other way, it's a microscope. Because we all had these devices when we were small children, but it's a lot of moving parts, and we try not to put moving parts on spacecraft.
Arjun is asking, would the goblin see an Einstein ring around the sun? Oh, good question. Hold on a second.
I
Goblin.
don't think it's far enough
At
away.
its closest, it is 65 AU, and I think at its farthest, it's 300. Oh, let me find out, because I think you get the Einstein ring at 550. So I need to get the. I
I
need the.
can't touch my keyboard without endangering the
No
life of my
problem.
computer.
So
So
it's
I'm just going to let him do all the Googling.
sure it's 80 astronomical units right now. All right, let me just see if I can get the actual orbital characteristics of 2015 TG387. I want to get its aphelion. Yes, 2037 AU. So
I
yes,
was wrong.
yeah.
Cool.
So at 550, I believe it would see the sun would be acting as a lens. At 1,000, you'd be getting the Einstein ring. So it would be the perfect. It wouldn't be the perfect. It would be a mediocre place to be able to. You would briefly get a chance to observe the Einstein ring around the sun. And of course, people are always asking, like, why can't you just catch a ride on a comet or catch a ride on an asteroid? But the reality is that if you can match the orbit of an asteroid, then you don't need to catch a ride on an asteroid. If you can get to an asteroid
No,
and land on it,
no.
then you never needed it in the first place. It was inside you all along. That ability. All right, let's move on. But that's a great question. Oh, there was a question that came earlier. Someone was asking, with those water worlds, could you, and I apologize, would you get a rocket? Here you go. Yeah, Arjun, could a rocket lift off from a water world, or would there be too much gravity if it was like a mini Neptune?
Uh, so it's always a matter of can you build a large enough rocket? And uh, we launch rockets from submarines here on Earth. The question is, how would a society that lived always underwater come up with the idea for rockets like this? You can imagine that this is a society that views potassium as death. Um, but maybe they come up with something. You're asking me to limit or expand the creativity of a society I know nothing about that has had to have a completely different cultural upbringing than what a human would get. So, um, yeah,
Yeah.
I don't know.
I
I
mean,
don't
there's
know.
of course the sea dragon concept of a rocket, where it's this gigantic rocket that just floats in the middle of the ocean and then blasts off. So there's no reason why you can't launch from an ocean. It's the higher the gravity, the more velocity, the bigger the rocket that you need. The tyranny of the rocket equation. That that a you would need a Saturn V type rocket to launch a tiny little probe into space if you had, say, double the gravity than what we have on Earth. So it's still possible. And you would need, I think, the entire mass of the planet to launch in 10 Gs. So if you turned your entire planet into rocket fuel, then you could launch in 10 Gs. So it's just what is the surface gravity that you're dealing with? And of course, those European space whales probably won't be able to build their rockets. Astro YYZ is saying, do transiting methods
Oh,
account for a teardrop effect like we get with, say, the transits of Venus, maybe making the length of the transit look longer than it is?
so that teardrop effect is an atmospheric blurring effect. So it's not that Venus is blocking any more or less light. It's just the shape of it is affected by the smearing of the atmosphere. So I'd need to go back and look, but I don't think that that teardropping affects the curve of the dip at all.
Right. But I'm just trying to think how you would get at seeing directly that water. I mean, you would use, as always, you would use spec
spectroscopy.
yeah, spectroscopy to
So,
analyze.
so you can surmise that the surface of a world is made up of ices based on its reflectivity, the
Right.
albedo of an object.
Right. Okay.
Uh, so it would be a all evidence points to versus a definitive answer.
And I know that there's a few ideas where you could potentially, as you said, you could watch the albedo of this planet as it is turning and go, it's not changing, therefore it's all the same thing, therefore it's probably water, or it's probably not water. And I
Yeah.
know that there's some ideas like if you could see a moon orbiting a planet, you could actually look at at the the light shining on the moon, the earth shine, and use
Yes.
that to figure out where the continents are versus the oceans, which is a pretty fascinating piece of research. And by the way, I mean, just a couple of days ago or yesterday, they announced potentially the discovery of the first exomoon. I don't know if you heard
Yes.
about that,
Yeah,
which
that
is
was cool.
yeah, so
Now,
cool.
one thing to keep in mind though is we can get foiled due to these worlds being covered in clouds because they're so humid. And so if a world is surrounded in clouds, you don't know what its surface is.
Right. Right. They all you get to see is the top. You don't get to see what's below.
Right. So you can imagine that a water world that is volcanically active and covered in archipelagos, if it has thick clouds, will look absolutely identical to another world that is pure water with no crust.
Ben Kalo asks what I think is one of the coolest questions I'm guessing we've ever had. If you had control over gravity, could you also control time? My son asked after watching Avengers Infinity War. So if you could control gravity, like if you were Magneto but for gravity, would you
Yeah,
also control time?
you could control the perception of time for people within a gravitational field because you're changing the field that light is moving through your greatly redshift. Yeah, you can change how fast within the gravity that time for those individuals is passing. It's the relativistic contraction. Um,
So I'm just
but
trying to think, right?
but you'd also be like squishing the bejesus
Right,
out
right,
of
right,
them.
right.
And you
Separate
could kill
separate
them in the
conversation,
process.
right? Well, like when we think
Yeah,
about Interstellar, they were close to a supermassive black hole, and so
right.
they experienced one day, and everybody else experienced 40 years.
Yes.
So
Yeah, that
if
would happen.
right, and so if you were gravity lad, then you could control the gravity, and you could create time dilation nearby you, where you would experience say an hour and someone else would experience a day
Yeah,
outside of that, but also you would be creating so much gravity that
death.
you would be scorched, so you would also need to have the ability to withstand enormous amounts of gravity, kind of like the Flash. The Flash,
Mhm.
as part of the Flash's ability to run at close to the speed of light, the Flash also has the ability to withstand the punishing environment of traveling close to the speed of light. So
Yes.
I like the question though. That's great. Pass that along to your son. Good question.
And Michael Mayer is once again giving me things that I'm going to have to Google later. I had not heard of that kind of drive. That
The
would be cool.
Alcubierre drive? That's the warp drive. That's the
Oh, dang
concept of
it.
the
I
warp
didn't know how
drive.
to spell it.
Mm,
Okay.
yeah. So that's the potential way of yeah, all you need to be able to if you want to have a warp drive, all you need to be able to do is control gravity. That's all.
Little things.
Yeah.
Little things.
That's it. Well, you know what? We've reached the end of our hour. Sorry, everybody. It's done.
Okay.
It's over. We finished. We won. We're back. Pamela is in Australia, but still clearly a trooper. Let's hope that next week's internet works well. And then after that, I think I might be traveling in Texas, so you might have to engineer the one after that. So
I'm happy to
yeah,
engineer as long as I'm home. I
yes,
could
yeah.
engineer this, but it would be a little bit messy.
Yeah, I think around the 16th, 17th, around then. So if you're back
Okay,
in the U.S., then
I
we'll
am.
engineer that. Okay, great. Well,
Okay.
so everybody, thank you so much. Pre-order The Universe Today: Ultimate Guide to Viewing the Cosmos with a stunning foreword by Dr. Pamela Gay. You'll laugh, you'll cry, it'll become a part of you. I will and sign up for Pamela's Astro Tour in the American Southwest. Uh, it's it's a look at the observatories and the amazing landscapes and the dark night skies in the Milky Way with Pamela as your guide. How could you not want
Yep.
to be a part of that? All right, everyone, thanks. Thank you to the Weekly Space Hangout crew. Go to wshcrew.space and join up with this amazing community. They are the producers of this show. They they really are a partnership with everything that we do. We couldn't do this without you. So, all right, we will see all of you next week. Have fun in Australia, Pamela.
I shall, and I hope I'll see a bunch of you while I'm here.
Right on.